Hello, everybody. Thanks for coming to my talk. I'm actually pretty excited. I wasn't expecting a big crowd with something that's named game architecture, so this is really exciting for me that it doesn't have to be a post-mortem of a game you've played for people to be into it. So thank you for coming to my talk. My name's Ryan Hipple. I'm a principal engineer at Schell Games. Schell Games Studio, we've been around for over 10, 15 years now. And we, at the moment, are doing a lot of virtual reality and augmented reality, or XR if you want to say that. So it's VR and AR. We've done a lot of work with theme parks, stuff with location-based entertainment, and stuff that you can ride in certain theme parks in the country. And we have a long history doing transformational games. The studio's up to around 100 people right now, probably around 110. You probably have played I Expect You to Die, which is not an educational game, but if you haven't tried it, we have a demo right now you can play in the expo hall. I recommend playing that. I did not work on that, so I can honestly say it's my favorite VR game without that being cheating. I did work on this one, Water Bears VR, which would be my favorite game if I didn't work on it. And we have a bunch of other games that we've worked on, but these are the ones that are the most accessible. All of them available on Steam. I Expect You to Die is on Oculus and PlayStation. And we have Orion Trail, which is out on almost every platform, which started out as a 2D adventure game, which is now in VR, and it's amazing and hilarious. So it's on the Oculus and I believe the Gear. For about 8 years, I've been working with Unity at Schell Games, and as a studio, we've almost fully transitioned over to doing all of our work in Unity. So watching that transition and being one of the first people that actually jumped in and started working with Unity, a lot of common patterns have been emerging. People tend to be able to find stuff online in the documentation or just from chatting with each other to understand how to do the algorithms that they need to solve this small problem they're trying to do. They understand how to write C#, they understand how to write code and get things where they need to be. But the big piece that's missing is the big picture. How do you get all of these tiny little parts of your game to come together and actually be a cohesive game? So I'm going to talk a lot about my approach to game architecture using scriptable objects as kind of the glue between everything. Can we get an updated timer countdown here? I need to keep track of my time. Before we talk about architecture, though, we do need to talk about pillars, which sounds super cheesy, but it's actually kind of true. At the studio, the way that I've been operating on projects, I've never really actually had to sit down and plan out, these are the pillars, these are the decisions that the things that I ask myself whenever I make a decision. But when I actually sat down to put this talk together, I realized that they've been there the whole time. I just have to put them in writing. So these are the things that, in my approach, what I use to make big decisions for how a game comes together. I want everything to be modular as much as possible. We want everything to be editable, either runtime editable or editable by designers, artists, anybody on the team. And we want to make sure everything is debuggable. So modular, editable, and debuggable. Modularity, what I mean by this is our systems are not directly dependent on each other. So if you have an inventory system, you want that to be able to communicate with other systems in your game, but we don't want a hard reference between them because it makes things less flexible and you can't reassemble them in new cool ways. Also, scenes as clean slates. I started trying this approach about 2 years ago, and I've been very happy with the results. This is the idea that you have no transient data that exists between your scenes. So you minimize, you don't destroy unload objects. Every time you hit a scene, it's a clean break, it's a clean load. This allows you to have scenes that have unique behavior that weren't present in other scenes without having to do a hack. If I see code that says something like, if scene.name is not equal to menu scene, I throw up all the time, all over the place. It's a mess. Also, prefabs, having them work on their own. This means, this goes very hand in hand with scenes being clean slates, where every single prefab you drag in the scene, as much as possible, having that prefab have its functionality contained inside of it, being a modular piece like a Lego brick. This helps us a lot with source control when we have bigger teams, where scenes are just a list of prefabs, and then your prefabs are the individual functionality. So you'll have most of your check-ins working on just at the prefab level, so you'll have fewer conflicts in the scene. And using components. Unity is a component-based engine, and it's one of its greatest strengths. As much as possible, break things up into components that do one thing and only one thing. And then we can talk about how we can get those components to communicate with each other. Editable. When I say editable, this should be kind of obvious. People can edit things. So the inspector is the #1 tool that we have to do that. But if we focus on data, if we try to make as much of our game data-driven and our systems just be these machines that process that data as instructions, we're going to be in a much better place to be able to make changes to the game, even when it's running. Also, it allows us to change the game without changing code. If we're component-based, if we're modular, it's easy to make your game editable. If we have lots of options for all of the things that our game can do, again, we want to allow for designers and artists to change things. And this leads to something that I kind of refer to as emergent design. What I mean by that is if designers are able to piece things together in your game without having to ask for an explicit feature, or if you're a coder and a designer and you don't have to code up the exact feature, you find yourself in a place where these tiny components that are proven to do exactly one thing and always do that thing right, because it's easy to test if it's a single outcome, you can rearrange those in different ways and find new game mechanics that you didn't know that your game even really accommodated. And we've seen some of the coolest features in the games that we're working on come from that sort of idea. And allowing it to change at runtime, super important for iteration. The more you can change your game at runtime, the more you can balance and find values. And if you're able to save your runtime state back out, like Scriptable Objects do, you're in a great place. And things being debuggable. This is kind of a subset. This works really well with the other pillars that I've mentioned. The more modular your game is, the easier it is to test any single piece. And the more editor features you have, the more editability you have, you tend to and also produce debug views for things. So making sure you can view debug state in your inspector and never considering a feature done until you have some plan for how you're actually going to debug it. And this is kind of unrelated, but it is my #1 rule that I will always state, that you never fix a bug you don't understand. You have to follow the bug, understand it, get to know its family, and then kill it in front of its family. So the pillars are have things be modular, editable, and debuggable. Also, bonus points if anybody knows what those pillars are from. Yes, Legacy of Kain, I'm buying you a beer. It's an open bar, so. So Scriptable Object basics. We'll look at some of kind of the goals of our architecture, but let's make sure we're on the same page about what we can do with Scriptable Objects. So here's our quick primer. It's a serializable class in Unity. It extends doesn't extend monobehavior, sorry. It's similar to monobehavior, but without a transform and no game object. And I learned from Richard Fine's Scriptable Object talk last year, which everybody should check out. It's kind of, I had to cut most of my material because he stole it. The monobehavior under the hood is actually, and the Scriptable Object are the same exact type on the C++ layer of the engine. So they're very similar. And typically, you'll save it as a .asset file. This is not necessary. You can actually just leave them in memory and work with them there. So you can create one with create instance at runtime and just use that as something that you reference. And even more fun is you can actually save more than one Scriptable Object into a .asset file. And I'm not going to get too much into that. I've spoken about that before about 2 years ago, the Hack Spectrum talk that I gave, where you can just pump a bunch of data objects into this so they maintain internal references and you can't accidentally delete something that's super important. All right, so some simple use cases that we have for Scriptable Objects. Some of these are great, some of these have problems, but these are the things that I've noticed teams do the most. Using it as a massive game config file. So how many people here are doing this with them, where you have a file that says, this is my path to this other object I need, this is the sound that I use when we click things. So this is a very common use case. In inventory, if you think of a simple inventory, it's just a list of objects. I'll go over some details on taking that a little bit of a step further and making it more modular. Enemy stats is another place, also from Richard Fine's talk. If you have a bunch of enemies, say 20 prefabs for enemies that have different visuals, but they want to behave the same, it's very easy to have them reference this enemy stats object, so that's a common use case. And something like an audio collection. Scriptable object as an asset that references 10 audio clips, and then you can ask it to give you a random one. So how does this relate to game architecture? Well, before we actually start talking about where Scriptable Objects fit in, I do want to address one of my #1 problems with the current trends with game architecture. We've got natural disasters, hurricanes, tornadoes, earthquakes, mass extinction events, the cancellation of Firefly, and that tiny piece of skin that gets up under your fingernail that if you pull it, it takes an entire chunk of your hand off. Also nuclear war. All of these things are caused by the same thing, and it's probably sitting in your game right now, singletons. How many people here are using singletons in their game? Show of hands, please, let's be honest. So I was actually expecting not applause. I was expecting everybody to be very upset with me on this because it's kind of one of those, it's almost a religious thing where the choices that you make when you build your game, you have to believe that that was the right choice. But it is important, since we're talking about something that's sensitive, that we are responsible, objective, and mature about it. So let's talk about the benefits. Why is it that people flock to this decision? Why do people use singletons if I'm saying they're as evil as they are? And also, when I was looking this up, I actually found there's a scotch called singleton. This is a real thing. If you just do a Google image search or Bing image search, this is the first thing that will come up. And I thought that was kind of funny. So you can access anything from anywhere. This, I think, is probably the #1 argument that people have, that why the singleton workflow is convenient within their game. If I have this if I have this piece of UI that wants to know what the player's name is so it can display it, playermanager.instance.name, done. I'm done writing this component. So that seems like an attractive thing. It's a very fast way of accessing any part of your code. Generally, the implementation allows for this persistent state. What I mean by that is the common Unity implementation that I see people do is their singleton will instantiate a mono behavior in their scene that they flag as don't destroy on load. That creates an object that persists across all scenes, even menu, which is why we often see if name not equal to menu. It's an easy to understand pattern, or kind of consider it more of an anti-pattern, but it's easy to understand, consistent, and easy to plan. So all of these things are very related. It's very clear I'm going to build the enemy manager, so I will just make sure it can access anything else, and then I'll build the player manager, so I'll just have that access the enemy manager. So that makes something much more easier for a team to go in and just start building things without having to put a lot of thought into how these systems communicate with each other. And just like the singleton scotch, this is when you go down in a small project in small quantities, it's something that works out. It has a lot of benefits. It could even make your workflow faster. But if you were to finish the entire bottle at night, you're going to find yourself with a lot of headaches. So down the road, if you do use singletons in larger projects, these are the issues that we've run into. The rigid connections, so that pillar of modularity, that's broken now. Having rigid connections between your systems means you can't just have one of them exist and not the other. They're all depending on the other ones being there. You're also removing polymorphism. This is, if we're using an object-oriented language, we expect to be able to take an instance of some known type and have that act differently based on what its actual type is. If I say player manager.instance, I'm asking the player manager to give me something. So I would not expect that to be able to give me the tutorial player manager, or the debug player manager, or the testing player manager. So we're breaking that contract that we have with an object-oriented language that we can get these specialized types back. And it's not very testable because of all of these things. Not being modular and not allowing for us to inject a different type of player manager makes it more difficult to test. And ultimately, what most of this leads to is it's a dependency nightmare. Aside from, we also have this global state, which means that when we jump from scene to scene or we go to place, it's not everything we want to persist, but some things will persist that aren't really what we want. The dependency nightmare makes it difficult to test things and makes it difficult to track, and you get race conditions that come up a lot in this sort of case. And there's a single instance, which shouldn't have to be spoken, but yes, a singleton has a single instance, and that can introduce challenges if you decide player manager doesn't make sense. We've got couch co-op now, so we need to handle 2 players. You could go in player manager and add an array, or same with enemy manager, but it does have this limitation that you're going to have to go back and revisit things if your model changes. So what are our solutions for some of these problems? At a high level, I'll talk about how do we reduce our needs for global managers? How can we build structures that don't force us to have this global state tracking? And having a model of inversion of control. This is a software design principle. The most common use case, the most common example of this is dependency injection. I'm not going to get into a very formal definition of a dependency injection within this talk, but the general concept of objects being given the things that they need to work with rather than going out and getting them is the approach that I want to take here. So instead of this piece of UI that displays the player name, saying playermanager.instance.name, something in the game needs to say, hey, you UI piece, here's the string you should display. I don't know where I got it from. Don't ask any questions. Just display this string. That will make that piece much more modular, reusable, and editable. But there's actually a lot of hope for this pattern. There are dependency injection frameworks that exist for Unity, which I'm not a huge fan of. One core piece of a dependency injection framework is called the injector. This is the thing that is responsible for passing references from system to system. And in my mind, that is exactly what the Unity editor does. That is what the inspector allows you to do. You can have a prefab that says, I display something, and then you can give it a reference to something that it can use to look up that string name. And along the same lines of this single responsibility principle, or every class you write or component, in the case of Unity, does only one single thing. Again, this aids in modularity, debuggability, and also allows things to be edited because you can add and remove components. So let's take a look at modularizing our data as much as we can. This is going to reduce the need for some global state that we can go to look data up for. Let's talk about an enemy prefab. So if we were to have an enemy prefab, and that enemy prefab needs to know what speed do I move. You can dial that into the prefab directly, but if you want to have 20 prefabs that look a little bit different or have some other strange behavior, but all move at the same speed, we don't want to, it's going to be really annoying to just dial that right into the prefab. One option is it says enemy manager.instance.moveSpeed. Give me my move speed. As I talked about, that has a hard reference, and that has potential, that dependency means that manager needs to be loaded. I have an example for an enemy prefab when we worked on The World of Lexica, which is a 3-year iPad game that I worked on, where we wanted to test our enemy prefabs in an enemy prefab test scene. So we could see the animations and see them respond to things. And we drag and drop the enemy prefab in the scene and hit play. Null reference exception. Can't register with the enemy manager. OK. Drag and drop the enemy manager in the scene. And this would be the same problem if it was just a lazy instantiation. Hit play, null reference. Enemy manager can't find player manager. OK. Play, I put in the player manager. Enemy manager can find player manager. Player manager can't find inventory manager. OK, put in the inventory manager. By the time we were done, we had pretty much completely rebuilt our game inside of our debug scene, and we had saved no time and made no progress. So reducing that dependency. Another way that people could have solved this problem, and this is something that Richard Fine talked about in his talk, is having a set of variables that are associated with the enemy prefabs as a scriptable object. So your 20 different enemies can reference that one set of data, and that's a really nice way of having that data get shared. But there's a challenge there, which means you're going to lump all those stats together. So now if you have an enemy that is a ranged enemy, and that ranged enemy needs to know what's my minimum or my maximum fire distance, that's now a new variable type that can't be added to this large definition. So this is going to break some of our extensibility and modularity if we use that approach. So what other options do we have? Well, I say we break them into much smaller pieces. So scriptable object variables are things we've implemented on different teams at Schell Games, kind of in different ways. But really, at the core, they're incredibly simple. I'm going to use the example here of a float variable, but we can replace float with anything else. Our internal systems, our framework that we use, has a much more generic version, so the code's fancier, not really good for demoing. So here I'm going to be defining a scriptable object. Create asset menu. That's something that's important to make sure you can create an object from the right-click context. Public class float variable that is a scriptable object. Curly braces on the next line because we're not monsters. .NET has standards. Thank you, yes. We're going to define a value. We're not naming this value. We're not naming it HP. We're not naming it range that we attack from. What the variable gets named in the project view as the file on disk, that's what's going to hold the name, that's what's going to hold the meaning. And this is something that a designer can do. They can make these at will and drag and drop those references places. And here's where the class actually gets really interesting. This is where it gets fun. So that's it. If there's anybody here that can't understand or complete this coding task, I'm sorry, the rest of it's not going to get any easier. So in this case, we can do hit points, damage amounts, timing data, all these things for enemies, and we can have those different components reference these variables. And we'd have some stupid enemy, of course, be on the next line because we're not monsters. And variable max HP is a float variable that this references. Same with move speed. There's something that can be really annoying with this workflow, though, and that's that this can get very cumbersome. We want every bit of data to be able to be grouped like this. But it's kind of annoying. Like maybe this one we just want to type in the float value. So we just made this layer on top of it we call the float reference, which is a serializable class. That we have this option of saying, do we want to use a constant or do we want to use a variable? And we just can go through that. And this way, designers can say, just use this data instead, or actually I want to use this shared data. With this pattern, once we actually look up the value, it's going to return the one that we would expect. But now we can go in and almost any float that's exposed in the inspector in our game, we now make a float reference. And it's made it exceptionally more powerful for our design team to use that to configure stuff and make sure that values are in sync across each other. So now our dumb enemy doesn't take a float variable, it takes a float reference. Simple enough. On top of that, I love doing over-the-top inspector work. We can make an inspector that makes this kind of fit into one line and be a lot more elegant to work with. And this seems like it could be a trivial addition to this, but it's my belief very strongly that making inspector, this was actually a property drawer, making property drawers to solve these problems that make it look like it's a part of the Unity editor is actually a huge benefit for your design team, because there's patterns that they're used to already, and my goal has been to convince everybody on the team that this is actually a feature of Unity, and that's happened a few times where a designer on the team that I'm working on now, we're on an older version of Unity, he said, I don't think I like Unity 2017, they removed float variables. So I'm very proud of that. So here we can, this is, going back to the float variable now. So now we know how to reference it. There's actually some functionality that is hidden in here that we might not have picked up on before. So we talked about having a designer specify this is max HP. These are all these other things like move speed. But we can do some other really cool stuff with this. That value, that float value, can change when the game is running, and anything else that's referencing that value will get an update. So if we think about the way Unity's animator works, it exposes something like move speed in this case, and it uses move speed as a condition to drive the animator. The animator doesn't care where move speed gets its value from. Again, it's just, I'm not going to question how you got to this number. I'm just going to use it inside of the system. Your components on the outside are editing the value of move speed, and again, they don't care what's happening on the inside of the animator. We have this nice layer of abstraction that allows us to test these things in isolation, and allows people like animators to work inside the graph and programmers to work inside the component. A better example of this, because the one drawback of this system is that that's a string binding. So move speed is a string, and you can use an optimized hashed version of it when you work with the animator, but it's still error prone. You still have to type in a string and keep them in sync. So I'd like to see Unity move this over to a scriptable object. That would be great for me. But also, there is a system in Unity that does operate like this. If anybody here has worked with a render texture, you know that there's two main ways of doing it. You can create a render texture while your game is running, or you can create a render texture with a right-click context menu in your project on disk, and then have your camera reference that. When you do that, it's obvious that the texture data isn't stored there, right? This is just a target for your data. There's some configuration on, the size of the render texture. But that doesn't own the data that's important that your UI prefab wants to use. Instead, the camera is going to write data into your render texture, and your magical piece of UI is just going to read that texture data. It doesn't know where it came from. It doesn't care that it's coming from a camera, and it just becomes this intermediate for a messaging system. So we're going to do that same type of thing with player HP. So if we have a player HP scriptable object, and we have a prefab called player in the scene. Let's say that player takes damage, and then they're going to subtract some amount from player HP. The player doesn't know what happens after that. The player doesn't know who cares about the player HP. But there's a health UI prefab, also in the scene, that happens to be referencing the same variable. So this can read that change in the player HP and just display a health meter that decreases. And this creates a new layer of abstraction where the player doesn't have to go out and say, UIManager.instance.health.update my number thing. Similarly, we can add new systems that care about the player HP. Our audio system, somebody can just come in and say, we're going to monitor this variable and use that to ramp up the music as your HP gets lower. Enemy AI can reference it, and you can imagine any amount of different systems referencing this. But there's a very clear separation that we don't have. The player does not communicate directly with these, and these things do not know about the player. They're just working off of the shared variable. I'm going to do a quick demo that shows some of this off. This has audio, so if it doesn't work or if it's super loud, I will pause it. Here we have, let's just call this the sphere of pain. It's just a collider that if this lovely cube collides with it, it will return the amount of damage that should come off of the player. So simple player has a WASD mover, not a component I'm interested in getting into here. But this simple unit health, if everybody, yep, there we are. This references this HP variable. And when the player collides with something, it's going to subtract a chunk. And when it starts up, it's going to say reset my HP to this max value. So here, let's get these WASD controls going. If I click on the HP variable, can everybody read this in the inspector? It says 100. And if I bump into something, very unceremoniously, it's dropping to 60, 80 every time I hit something. Let's turn on the HP meter. This is just a prefab that's completely isolated, referencing that object. So you can see the HP meter's in here now, and that's going to update. Again, this HP meter is just a component that I made called an image fill setter, incredibly small, simple. It's using the Unity image class and setting its fill amount to the HP divided by the max HP, which are all variables. Very simple component. I can click this and drag, and we can even see this update in real time. If we're testing our meters, you don't have to have a player in the scene. You could just have an empty scene that has your UI, and you can test everything out. So that can save your UI designers a lot of time. Let's add, whoa, I don't want that. Let's add a warning sound. So now, when the player's HP gets low, we've got a new type of component, very simple component, watches an HP variable, and says if it's below some threshold, play a sound. Again, the source code isn't really the focus here. It's more the idea of how these things are glued together. So let's drop this. I'll just do it the quick way. If I drop this down, we'll hear, yeah, the low health heartbeat. So let's bring that back up and see if we can make that fancier. So here, this is the exact same object with one additional component on it. So we've added a component and added functionality. We haven't had to change anything. We haven't had to delete anything. This now takes the value of HP, compares that against a curve, and uses that to change the pitch of the mixer of the heartbeat sound. So now the lower our health gets, the pitch will increase, and I will show you, so to prove that I'm not lying that it just works, because that would be a waste of my time. So here, if I drag this down, you can see that the speed will increase as the HP drops. And if this were to be deleted, or if the player wasn't in the scene, all of these systems would still work, and we can just add new functionality with a very minimal risk of breaking things. Not the scene. There we go. Nope. Yeah. All right. So using these variables is a useful way to share data between systems, and it also, this form of the data has some sort of persistent state, where if you load from scene to scene, since it's in memory in a scriptable object, in the in-memory copy, your next scene will be able to access that same data, and that's very useful for something like player HP. But there's a lot of cases where we don't actually care about the data that we're passing. We just want to say, something has happened, and I would like you to respond now. So now we're going to talk about event architectures. Also, surprise, I'm going to use scriptable objects. An event architecture helps modularize systems, much like these float variables do. And it lets you reuse them in other projects. At our studio, we have a lot of projects running at a time, and we have our own Unity framework. So something that we can do to connect these framework modules to our project is always something that we need to come up with when we start a new project. And using an event architecture allows you to just drag and drop something in, and OK, the bindings between this and the systems in our game, we'll make those be events. It helps isolate prefabs, much like those variables. And a prefab can say, I respond to an event, and I don't care where it comes from. So if you raise it, I'll do whatever my prefab tells me to do. And it's a little bit of an optimization over the model of the variables. So an HP meter, you might want to have that watching closely if your HP is a wide range. But in a lot of cases, you don't want to be busy checking, what are you now, what are you now, what are you now, what are you now? And instead, just have a one-off event. It's also highly debuggable. If you can invoke these events through the editor or through other systems or through a UI, it's easy to identify if the event's raised, is the behavior correct? Yes. Well, is the event being raised? Yes. And if you go down that search flow, you can kind of do a binary search to hunt down where your bug's coming from, on the raise side or on the response side. Unity has this thing called Unity event. That seems like the first place I should look if I want an event in Unity. This was introduced, I think, in 4.6 with the UI system. So its primary focus was what happens when you click a button. So it looks like this in the inspector. You can pick an object, and once you select an object, you get a drop-down of all the functions that you can call on that object. So here you can call otherthing.setActive to true. This is, in my mind, not really an event. It's a very useful tool, but this is actually more of a serialized function call because you're saving out ahead of time exactly what you're going to do. There's some advantages to this. This is still a very useful pattern. We use it everywhere. You can hook things up in the editor. So this allows for things to be modular. And you don't have to have code, that sort of last meter that connects one system to another. You can just do that using these Unity events. So your code doesn't need to assume it's bound to a button or it's bound to a collision. It allows you to pass arguments. I'm not going to get into depth on that too much, but it's one of the things that people don't always use with them. You can extend Unity event with whatever type of the argument you want to pass. So Unity event bool, and if you declare that as serializable, you can use that new class as something that you can pass data with. When you do that, the arguments are either static or they are dynamic. So let's take a look at on example needed with a Boolean. So otherthing.setActive, if you click, you get this new section up top that is dynamic arguments. So at the bottom, you have arguments that you can just specify in the inspector. And if you select one of these, this means that it's going to wait for the event to be raised in code with an argument, and it'll forward that along. There's still some problems with this. As I mentioned, it isn't really an event system because it relies on rigid bindings. So if you use an event for a button response, that means a Unity event for a button response, that means that that button needs to know exactly what object responds to it. So if you want to keep your UI in its own prefab, which I would recommend, and have some system that's not in that prefab respond, you have a challenging system now. Now you need to make an awkward class at the top of your prefab that responds to every single button click, and when you make a new button, you have to go in and make a new response. So this becomes a little bit of a problem when we're trying to modularize and extend things. Yes, the hard references in the button are the problem. And there's some limited serialization with Unity events. The capability of a Unity event far surpasses the serialization model that they use for the Unity event. What I mean by that is with the Unity event, you can define something that takes up to 4 arguments, and those arguments can be just about anything. But the only ones that you can actually edit in the inspector are if it takes 1 argument, and the argument is an int, bool, string, one of the first-class primitives that Unity treats, or Unity engine.object. So you do run into some issues when you're trying to serialize out different Unity event responses. And also, there's a garbage allocation. Since it's a serialized function call, it's using the string to resolve what message gets the response. So every time you call that, you're going to see a little bit of garbage. This doesn't make them useless. That just means you don't want to call it every frame. If something happens every frame, it's not really an event anymore. So how do we extend this? We're going to try just making our own events. So we want to make them data-driven, obviously. Make sure that they can be designer authourable. So again, probably going to be a scriptable object, spoiler. And make sure that they're debuggable. It's going to look a little bit like this. Create asset menu, because it's a scriptable object. We'll call it game event. Curly braces in the next line, we're not monsters. We'll have a list of game event listeners. And all this really is a class that I'll get into real quick. What happens when we call raise on this game event? It's going to loop through all of the listeners and call on event raised. An interesting thing about this loop is we're looping through this listener list backwards. And the reason why that's a useful pattern to use is in case an event's response or a listener's response includes removing it from the list. That way you're removing items behind you instead of removing items in front of you. So you can iterate through the list without an out of range exception. And then 2 functions that are not super important to really define, register and unregister, just add and remove it from that list. There's a lot of optimizations based on the number of listeners you would have in this thing. You could change to different data structures, but kind of as an abstraction on the system, the list is a good starting point. And always end your classes. So the game event listener, this is the other half of that. This is a mono behavior. So the game event is a scriptable object. Game event listener is a mono behavior. Oh yeah, next line, not monsters, whatever. The game event is something that's referenced. So this is in the inspector. You can drag and drop the reference to the game event you want to respond to. And then use a Unity event to serialize the function call as the response. So now if you have a prefab and you have an event listener at the top of your prefab, you can decide what message do I listen for that's going to come from outside of my prefab. And then what response do I have inside my prefab? So now it's much more reliable. Your Unity event knows exactly what, or the objects that's responding to this event knows what the context of this prefab is. So it can have that Unity event response and not need to rely on external prefab data. And in this case, we'll say when the object's enabled, it registers itself as a listener, and when it's disabled, it unregisters itself. And this shouldn't be a surprise. When the event is raised, it's going to call response.invoke. I'm going to show a demo. I'm going to jump into the same cube exciting game here. This is kind of the where we left it off before, but we're going to add a damage effect. So we wouldn't want something constantly checking the HP saying, did I get damaged? Did I get damaged? Did I get damaged? So we'll make this work like an event. Here I made an addition to this unit health class. No, spinny bar. When there's a collision that happens on this player object, it's going to invoke this damage event, which is just, here it is in our scene. We can create it by saying create, blah, blah. It's in here, I swear. Game event, just like that. So player says game event.raise. That's what this Unity event's going to trigger. Then somewhere else in the scene, or maybe it doesn't even have to have a presence in the scene, we'll have something respond to that. So here we have game event listener. So this is just a component that all it does, this is what we talked about, it listens for an event and calls a response that is a Unity event. So it listens for on-player damaged, and the response is emit 40 particles and play a sound. So you'll love my programmer particles. But as this happens, it just gets that event. As far as debuggability is concerned, if you just write a simple inspector, you can come in here and click on player damaged and raise that event as much as you want without actually having to recreate whatever setup gets you to that place in your game. Player damage is simple to recreate, but a lot of events are much more complex in our games. We can keep adding to this, and let's say when the player dies, there's now 2 new prefabs, death sound and death screen. Programmers don't even know that this stuff's happening because an artist can just make this thing that responds to an event and turns on. So here, when the player dies, we're going to raise this on player killed, and it's going to turn off the player object. So let's make that happen. So there we go. I forgot to not have a broken bug. Sorry. There's supposed to be a bug right here so I can fix it in front of you. I guess it's a bug that there's no bug. So here, I'll reintroduce the bug. So now the player's dead, and the heartbeat's still going, which is very annoying, and very clearly you're going to get somebody reporting that to you in QA as a bug. When you're in late stages of QA and you can fix something in your game without having to write any code, it's so much less stressful. You don't have to retest all of the systems, just that one thing. So here's how we would fix that. We have this warning sound. All we need to do is add a game event listener to that. That's going to listen for player killed, and the response will be to turn itself off. That's it. So now when I play, which you've all seen this before because it wasn't not broken, it turns off the sound. You can see that this game object has been actually turned off. So now we've fixed a bug by just adding one single component that affects only that object. So scriptable objects are great for this modularization of data, making things into smaller pieces and smaller messages, but there's still some things about like the singleton pattern that we haven't solved yet. So one of the big things that a singleton still wants to do is they want to have, in the case of an enemy manager, you want to track all the enemies in a scene. So every time an enemy gets placed in the scene, it's going to, on enable, say, hey, I'm here. And that way the manager has this high-level view of everything in the scene. This still can create race conditions. Similarly, an enemy manager would want to understand where the player is, and it would want to take that list of enemies that it has and say, hey, do this thing to this player. So there's more than just a collection of data there. There's actual functionality that's implied. And we can take a look at this and see what some of the problems are. As I mentioned, there's race conditions. I'm sure many of you have been in a world where you put an object in a scene, and player or enemy manager.instance is called and it hasn't been created yet, so you get a null reference. Or it's checking if it's been created, and if it hasn't, it doesn't respond, which means that enemy doesn't get added to the list. Also, we're dealing with the same rigid singleton problems, where if we have an enemy manager that does this stuff, we can't do that test scene that I talked about where we placed a bunch of enemies and we needed to bring in every other system because of its rigidity. And still, there's only one. So we can address these with this feature I call runtime sets. These are going to be almost exactly like the float variables, except instead of a float, we're going to be dealing with a list. So we can keep track of a list of all the objects in the scene. That's one of the goals with this. It'll avoid race conditions, because if you're referencing a scriptable object, its in-memory copy is available when you reference it. You don't have to manually initialize this. It's just there. And it's going to be more flexible than using Unity tags or a singleton, and more performant than calling find object of type. So Unity tags will let you say, yes, I'm an enemy object, and there's a special list maintained of all of your special tagged objects. That's also using strings, so it's very likely to be error-prone. And you can only have one tag on an object, which to me that's not really what a tag is. That's more of a label. So we'll take a look at how we build these. Also very simple. Here I'll just do it as an abstraction because it is a little bit fancier. So we'll have a scriptable object that has a list of items. In this case, they could be enemies, or in my example, they will be cubes, because that's very exciting. An add that will add it to the list, much room for optimization on the list here, I'm sure, and a remove that will remove it from the list. Also, all very simple. And this is all stored on a scriptable object, so you can have something in your scene reference that object. And we've used this type of pattern before when you have an RTS game. When you place a building in an RTS or build a unit, you want something that has an understanding of what are all of the units, what are all of the buildings. It's also very common that when your game is fully in production, you'll have maybe a designer says, oh, but I also want to maintain a list of the flying enemies. And we don't necessarily have coding resources available at the time to code in a new list of flying enemies and the rules for looking that up. So we could very easily just say, this enemy, or here's a new component that says add it to enemies list. Also add it to flying enemies list. And then we can maintain these lists kind of just based on whatever components we add. We also use this, and actually this was the first time that we started it, was for special effects. So we had a custom renderer that our graphics engineer, Joe, wrote. And here we needed to reference some renderers and do some dirty stuff to them to get some really cheap and nice blur and glow on them. So our rendering script needed to know about every individual renderer. And since our graphics engineer isn't a full-time member of the project, he shifts around and solves really hard problems for all the projects, there wasn't a lot of time to understand how the game's all put together. So instead of actually having this integrate with some big part of the system, it just put that into the in-memory copy of the scriptable object, and then we were able to, on start, we would have all of these special renderers write themselves to that list, and whenever the camera went to render, it would just go through the list and say, hey, here's a new renderer. And it didn't care where that data came from. Similarly, you could do this with items on a mini-map, so anything that wants to display on your mini-map can add itself to a list, and your UI component can inspect that list and say, for each item in here, we're just going to draw whatever icon we associate with it. And I have a demo that is less exciting than any of those, but it demonstrates this with cubes. Cubes. There we go. So here we have a handful of things. These are just the ugly cubes. This thing component references a runtime set, which is a scriptable object. And what this is going to do is when we click on any of these things, when these things are enabled, they'll add themselves to the list, and when they're disabled, they'll remove themselves. This enabled things scriptable object this is not a system, this is still just a collection of data. Meanwhile, we have this thing in the scene, the disabler. This has functionality to disable a random item in the list. So if you could imagine this expanding to be something that's going to be your enemy target. This is responsible for assigning targets to enemies. So instead of just simply disabling a cube, it says, some amount of time has elapsed. I'm going to pick an enemy in this list, a random enemy, and assign him to attack the player. So now this is a system that doesn't need to know about specifics in the scene. It's inspecting a scriptable object. That means that reference can be maintained between scene loads, because this is a prefab referencing an asset. It's not referencing anything else in the scene. So there's also a text in this canvas here that says there are 5 things. That's just text that's inspecting that list and just printing out the number. So you can have a lot of things that kind of just operate on this as these observers. That's an observer pattern just looking at this set of data. But if I click disable random, it's going to do what we expect, which is it'll send an event using our game event system to the disabler, which will just disable one object from that list randomly. And again, you can see that these are all simple components. This doesn't make any assumptions as to where these objects come from. It just says, I'm looking at a list somewhere, and it's a dependency that's been injected into it by the inspector. OK. I also wanted to talk a little bit about enums and how they relate to data and scriptable objects. This is another thing that Richard Fine talked about in his talk. But I think it's important to bring up again, so I'm going to go through this kind of quickly, but yeah, he stole it from me first. Some of the limitations with enums, with enumerations, that they're all code-driven. And I think that the more code you can remove from your game, the less bugs you're going to have that are programmers' faults, so you can just assign all of your bugs to the designers, and everybody's going to be happy except for the designers. So if you have enums, you're going to have to change these things in code. So if we have elements, your fire, ice, and wind elements, I can bet you somebody's going to ask for a new element at some time. So using an enum for that is something that you know you're going to have a feature add. They work out with things that are relatively fixed by some law. So cardinal directions, north, south, east, west, that could be an enum, unless your game, of course, wants to go into a more gradient space. We've used enums for comparison operators, less than equals, not equals, greater than equals. So that's a place where there's not a lot of new comparison operators being invented every day. But that's a space where enums make sense, where you have a relatively fixed list. Using the enums and having them all be code-driven, they're difficult to reorder or to add or remove things. If these are serialized, the enums are going to be saved out based on their index. So if you delete one, you're going to break every single thing that uses that. I've seen games deal with this by renaming something to unused, and then that way they maintain the indices of everything that comes after it. And then you've got this massive list of enums that have 3 things that are valid because you don't know where they're actually being used. And then finally, they can't hold additional data, which is kind of obvious. You end up building sort of a lookup table in a lot of cases. And even if your initial definition here is we don't need it to hold additional data, somebody will. Somebody will want to put some data in there. And when you use your initial limitations or your initial expectations to define your implementation, I think that you'll realize that, yeah, that's a self-fulfilling prophecy. It can't do that, therefore it never will. So we can solve this, of course, with scriptable objects. Demo. So here we'll look at elements, and I'm going to look away, sample data. So here we have a handful of my favorite types of elements, rock, paper, and scissor. We all know how these work. I didn't write a fancy mover, so I'm going to drag things around in the inspector to demonstrate what happens here. These cubes each have an elemental component, which just references one of our elements. This is a scriptable object that extends, that is of type attack element. So here, all of this lists is what are the things that I beat. We know paper beats rock, rock beats scissors, scissors beat paper. So if I grab the scissors and drag them around, scissor on scissor, oh, that doesn't sound good. That does nothing. We'll edit that out. Scissor on paper, we know what's going to happen. Scissor on rock, that's exciting. It just died. So that's a very simple elemental system. But inevitably, you're going to have a designer come in drunk at night and say, I want dynamite. So here we go. Let's add dynamite. We all work with that guy. And dynamite beats everything. It beats rock, it beats paper, it beats scissors, it beats dynamite, which is just devastating. And I'm going to turn on these 2 special things because I knew I was going to do this. And we'll drag and drop this new dynamite right here into the element. So now these 2 at the bottom are going to be dynamite. So what I've done, and I could also have done this when the game was running, by the way. But what I've done here is I've just added a new feature, dynamite, going through, cleaning everything up, and just being destructive. So now we've added this new feature that this small example wouldn't have been too much of a drain on your programming team to add one thing to the enum, but it's as your game starts to get larger, these things get to be much more expensive. And this also wouldn't break your reference index if this ends up getting deleted or reordered. Okay, so we've talked a lot about modularizing data, and that's all well and good, but there's still things that you can do with, you still need more than just data points, these small chunks of data, in order to build your game architecture. So just like we can reference a variable that only has a float, we can also reference a scriptable object that contains the entire definition and all of the code that gets executed for a system. I'm sure everybody here knows that you can write functions inside of scriptable objects, but there's this sort of mental barrier where most people I talk to, they avoid it because they look at it as this is a data bucket, it holds data. But you can write any method you want inside of that. They don't respond to most of the Unity events, so they don't have an update tick, which means that they do only what you tell them to do, which is kind of what you want code to do. So here we can go through an example of how we make an entire system packed into an asset. So if we make it a scriptable object, that system lives in the project, and it can be referenced by other prefabs or by other scriptable objects. You're going to just build that reference directly with the inspector. Again, this makes the inspector act like an injector in a dependency injection system. This makes it easy to see what system something's relying on, and it makes it easy to debug if there's, well, also you won't have race conditions with startup here because these scriptable objects are available on demand. There's also no code lookup, no inventory manager.instance, so this is very flexible, and you can even swap out what you're doing with your inventory manager. And you don't end up with any references in your scenes that say, oh yeah, here's my inventory manager game object, if you did it that way, and this UI has a reference to that. That's saved in the scene data, and if you were to move any of those prefabs to a different scene, they wouldn't function. So let's take a look at how the audio mixer and the mixer group do this. The audio mixer has an option of selecting an output mixer group. So in your project view, you have one, and you drag and drop it in. So this is the pattern that Unity uses that's very much the type of thing that what we're looking for. I also want to give an example here for specifically an inventory system. On the game that we're working on now, we had an inventory where you have abilities. So it's an inventory of abilities, and there's a sort of telekinesis ability that your player has. And in our tutorial, we're going to teach you how to use that. But there's a problem that you can repeat the tutorials, and we don't know what the state of the player's inventory is at that point. So on past games, I've seen this be implemented by somebody saying, oh, we're just going to go in and modify the player's inventory. Instead, in our tutorial scene, we would just drag and drop a reference to a new material, to a new inventory. So we had a tutorial inventory that had only the item we were teaching, and then that was the one that we would reference in the tutorial scene, and we didn't have to make any code changes to support that. Right, so this inventory contains a master list. This is all of the items that are available. It has one scriptable object per item. This means that on source control, changing an item doesn't change this massive asset. And we have a lookup that happens on validate of the master list, or you can have it happen on other asset events that will just automatically populate it with every item in the scene, or in the project view. And as I mentioned, we can use different inventories in different scenes, like the tutorial example. So here we have an inventory asset that is the hub of our system. The player references that, because the player says, my equipment, so display all of my equipment on me. We also have maybe the equip screen reference that. So now we need to have a prefab that's UI. This can have a direct reference to that asset. And that asset can then modify the inventory. And we can imagine an NPC wants to have access to the inventory. So this is where the NPC can say, I'm going to give you an item. And they don't need to know that the player is around. The player doesn't need to be in the scene. We don't need any special objects to exist. The player just says, I'm going to add this item to the inventory. And now here's where things get interesting. You can have your systems, so if you have an inventory system, reference other systems. So in this example, we can see our inventory can reference our save system. We could also have our inventory reference our localization system if it needs to do a lookup of text. So these are scriptable objects. The references that you tie between them are all going to be saved in your project view, so they'll be things that are guaranteed to always exist. I want to leave some room for some questions, so I'm going to skip over the inventory demo because I've just walked you through how it works. That's just about it. I want to remind everybody that the goals here have been to keep things modular, editable, and debuggable, which is going to let us make sure we can focus on building game architectures that are reusable across different projects, across different scenes, and hopefully across different studios. So I think that the game industry and the Unity community gets better if we're using similar practices. So I'd love to hear some questions at the microphones and some comments, and if you want to pick a fight over singletons, I'll be at the Unity party today. Thank you. Please use the microphone for your questions.
Yes. So I've got a question. One side effect of abstracting all of this is that you, for example, in the code, you can't look like references and such. Do you guys have had problems with it, like with debugging or with people that are new to the team to see like, okay, where's this thing being called from? It's a public method, so something out of, like something is calling it, which is why we, for example, don't do that.
So I showed some well, first of all, I can answer that. The samples that I showed were very simple examples that are very subject to that limitation. Tracing them gets more difficult. We have many more layers on top of that, and one of them that we've added is for our events specifically. Any invocation in debug mode is logged and displayed in the inspector. So it'll give you a full stack trace of where that was raised from. It also maintains a list, and the way that Unity handles serializing in a scene versus in the assets, so it uses the instance ID rather than a GUID and file ID. You have to do a lot of fancy work to maintain the display. But we have our events, our debugger for our events also let you see every single thing that's registered. So in the inspector, or even in the scene view, you get little gizmos inside of our scene that show you, hey, I'm listening for this event, I'm listening for this event. So we've built all of our tools that we've built for it to kind of focus on solving that problem. But one of the costs is that. Like you have that layer of abstraction, and you're pushing a lot of that to data. So the power of giving designers control is that they can make patterns that still can be challenging. So there's still a lot of discipline required for it.
Cool, thanks.
Yeah, thanks. Yes?
Hey, Ryan, thanks for the talk. That was really useful.
Of course, thank you.
Great collection of patterns there. Have you thought of publishing this as a blog post or open sourcing that project or something?
I'm hoping to make a cleaned up version of that project and put it up. I might put it up on GitHub. If I do that, I'll probably tweet that out in a Twitter account I use once a year. So if I put that up, I'll definitely post that. As far as blog posts, Schell Games we have Schell Games or Schell Labs where we have a lot of our developers do blog posts. When my project wraps, it's pretty busy right now, it's very likely that I'll be contributing to that to put things like this up there.
Awesome.
Because there's a lot of examples I had to cut. I had 2 hours of stuff, so.
Great, thanks.
Hey, so we had a lot of similar problems that you showed here, but we went a sort of a different approach on how to solve them. So we're using dependency injection framework.
Yeah.
So there's basically just one Zenject, something like that called. And it kind of solves a lot of the problems that you showed. And I'm just wondering, did you ever think about that, or what are the benefits of using dependency injection versus your examples?
We've talked about dependency injection a lot in the studio, actually. We do a lot of client work at Schell. I listed the games that we've made, but we probably do 60–70% of our work for clients. So a lot of the times we inherit their processes, which gives us a good view of alternatives. So we have a team that's been working with Zenject specifically. And I think it definitely addresses a lot of those problems. The thing that it doesn't address for me is it doesn't expose things to the design team. Yeah. So it's taking everything outside of the inspector. So that's where it breaks down for me, and this really depends on how comfortable your team is and what your team breakdown is. But like my current project, it's a handful of programmers and one designer, but he's a very technical designer who's good at exploiting systems. So it's very nice to be able to say, we've given you all of these tools. If you use them, they'll follow their own rules, and if there's a bug, it's on us. And if there's a bug with how the systems work, it's on us. If there's a bug just with how all of these things come together, we have a big behavior tree, that's on you. So it allows us to have that big separation of responsibility by just pushing it into the data space instead of into the scene. But Zenject is something I've heard a lot of good things about.
Thanks.
Hi, that was a great talk.
Thank you.
I'm curious, it seems like this sort of approach emphasizes like serialized behavior almost. So like a lot of systems or like event handling is set up via serialized references. And I was curious how you guys have managed code reviews and looking at diffs and source control compared to like normal code where you can like look through references in your IDE and you can easily see like code in the diff.
Sure. From the code review perspective, depending on the project, we have different standards for a code review, and that usually is something we inherit from clients. On one of the projects we're using now, we're using Git and a little bit of a Git flow model. So at the end of the day, we're in QA, so at the end of the day, we have this nice review of everything that's been done. If we make a change that adds an event, so often our bug fixes are, oh, we just need an event to fix this problem, we need to listen for this, player died, turn off the thing that we don't want on. The way that actually serializes in the YAML is pretty readable, at least for our team. We're comfortable seeing, okay, this is very clearly an event because it says event name this, response this. So when the components are very small, it's easy to pick those things up. But I will say that yes, the biggest drawback is that you cannot trace it all through code, and that is also one of the biggest benefits that I see.
Interesting. Thanks.
With a system like this, is there any cause for concern for something like memory fragmentation or something?
I think the way that the assets are loaded. You mean memory fragmentation as it impacts performance?
Yes.
So far, no, we haven't run into any issues for this. We're running on, our current project is on mobile devices. We're not necessarily targeting the highest end mobile devices, and we're using this extensively. It depends a lot on the needs of your game. So what we're doing is we have a scene that's essentially a battle that's very self-contained. We understand what's happening in that. So for us, that's been a model that works really well, that hasn't been too demanding to cause memory thrashing or problems with that. But it would be something to look out for if you have a larger scope.
Have you tried doing any like profiling on where data is stored and stuff in the game, or?
As far as profiling is concerned, nothing really shows up in the profiler for this. It's all the profiler hits that you get that we see would be the memory allocations, the garbage allocations that happen when you use the Unity events, and that's where we actually have the option of using a Unity event, or we can just register something with an interface that says, I'm an event listener through my interface, therefore it doesn't have that overhead. So we do have some optimal paths for things that happen more often.
Thanks. It seems like the focus is that scriptable objects primarily replace singletons.
I wouldn't say that. I'd say I've run into a lot of issues that come up on projects where the core of the architecture is connections from singleton to singleton to singleton. That's not to say that some stub system, especially from some API, being implemented that way doesn't mean that's the end of the world. It's more about maintaining those connections, and the scriptable object can replace a lot of things, and one of the things that it can replace is global. It can help you manage global state or references between things.
Okay, another question is, you could also use game object with a monobehavior, right, and do like kind of all the same stuff.
You could. So the limitation there is if it's a game object and you
project.
serialize a reference. Oh, a game object in your project.
Yeah,
yes.
It's not instantiated.
Yep, an uninstantiated game object works exactly the same, except it has the overhead of a game object and a transform. So if you need the game object and transform for whatever reason, you can do that, but they do work exactly the same. So it's more of a syntactic thing where you're saying this is what we expect this to operate like a system and not be instantiated. You cannot instantiate in your scene a scriptable object.
Right.
So it's kind of more that is what it's intended for, and you don't want somebody to accidentally instantiate your weird system.
I have one other question. For some reason, I remember that if you changed at runtime the data of objects that was like in the project, that it would remain changed after play stopped.
It does, and that can be a good thing or a bad thing. So if you're changing some balance variable, that's something you can do. And
Like
we
player
actually
health.
we have an index that keeps track of all of our variables that takes care of resetting them to their default state.
Okay, so like if you had a player health with like the bar and things are all looking at that player health, something has to reset it to some.
And in that example, it would reset it on start to the max health. I'm getting the sign that we're out of questions. So if you have more questions, I'd be glad to talk to you after this. Thank you.